So first, let's go over a few preliminary terms that you need to know. So the first is length. So length is a measurement of in one dimension. So it could be width when there is second dimension and depth, which is third dimension. But all of them are essentially a measurement in one dimension. So measuring how long something is. Pretty straightforward. Angle is the incline between two intersecting lines. So basically when you have two lines which are crossing each other, sort of like the space between them, actually not really the space, sort of like the incline between them is the angle. Okay, and we usually write angle in degrees or radians. In radians you don't use in general maths, you only use degrees. And I also just want to preface this by saying space and measurement has been removed from the Units 3 and 4 General Math Study Design, so you don't cover this next year. So this is sort of like just Unit 2 stuff only. Then we have area. So area is a measure of space in the second dimension. And then finally we have volume. Again, it's a measure of space, but this time in the third dimension. Okay, so first let's look at similar shapes. So what are similar shapes? So similar shapes are objects which have the exact same shape but a different size. So here is an example. So which of the following sets of two shapes are similar? Okay, so to answer this question, what we need to do is consider the different lengths that exist in the shape. So we either have, so this time we have just two-dimensional shapes, so either length or width. So what we do is we look at the ratios between the different sides. So here we have the length, which is 4 centimeters, and for the bigger rectangle, it's 8 centimeters. So I can sort of see a ratio here, so it's 1 to 2, okay? Or 4 to 8, which can be simplified to 1 to 2. So thinking back to ratios from Unit 1. Okay, now what about this length over here? Is that in the same ratio as well? And yes, I can see that it's 1 to 2 as well. Okay, so that we call a similar shape. They're a similar shape because they're the exact same shape, just a different size. So one has just been sort of like expanded, but it's the exact same shape. Now this one, this side still has the ratio 1 to 2, okay? But these sides have the ratio 4 to 7, which cannot be simplified to 1 to 2. So these are not similar shapes because they have different ratios, okay? So for something to be a similar shape, all sides need to be in the exact same ratio. Okay, so now let's look at scale factor. So for shapes that are similar, we can have something called a scale factor, which basically tells us how much bigger a particular shape is compared to the other shape that's similar to it. And the way that I like to work out the similar factor, or the similarity factor sometimes called, or the scale factor, is take any random side that you think is the same in both of them and just divide those two sides by each other. But always take the large shape minus the smaller shape. So for example, in this one, these two sides are corresponding to each other. And all I did was take the length of the larger shape divided by the length of the smaller shape. And that will give us 2. So that means the scale factor for this shape is 2.